Hello and welcome back to MetaMath. In this video, I'm going to be covering problem 22 from the 2020 AMCA test. If you're interested in seeing solutions to the rest of the problems from the 2020 test, please check out my playlist, which I'll be linking in the description below. With that out of the way, let's get right into the problem, which reads as following. When a positive integer n is fed into a machine, the output is a number calculated according to the rule shown below. If n is even, n over 2 is the output, and if n is odd, 3n plus 1 is the output. If n is equal to 7, then we have this sample sequence here that starts 7, 22, 11, and so on until the sixth term is 26. Now, the problem is asking us if we applied the six-step process to a different starting value of n, and the final output is 1, what is the sum of all such integers n? So we have to find the values of n that if we started with and applied into the machine 6 times would give us a value of 1. And this is difficult to do forwards or applying the value of n at each point because we don't know to start off with if n is even or odd. If we knew right off the bat if n was even or odd, then we could go ahead and write the second value in terms of n. And if we knew more about n, we could perhaps do it for the third and so on. But because we don't know if n is even or odd, we can't really write n over the second term in terms of n and use that to solve at each step for what n could be. That would involve a lot of casework, and basically we'd have around 2 to 6 possibilities because we'd have 2 possibilities at each step, and that just end up being a lot of casework. Now, what we do know is that at each possible output, n over 2 or 3n plus 1 is going to be the result, so we can use this to work backwards. So we know that the last term is 1, and because of that, we can use that to find each previous sequence. And this is a lot easier to explain when we actually do it. So let's go ahead and start finding some possible sequences. So let's starting off with our first case here. If n is even, or the number before 1 is even, to avoid variable confusion, let's call this number x. If the number before 1, which is x right now, is even, then the value we get is 1 because x divided by 2 gives us 1. So we know that x would have to be 2. So that is one possible start to our sequence if that number before 1 is 2. Now what if we had 3x plus 1 is equal to 1? Well, we'd have x is equal to 0. And not only does that not satisfy the criteria that x is odd, it does not satisfy the fact that all numbers in this have to be positive integers because the first number was a positive integer, so all the following terms have to be positive integers as well. So because of that, we know that this does not yield a valid solution. So we can do this one more time and try to figure out the term before 2. So once again, either it's going to be double, in which case it's 4, or we can solve 3x plus 1, this time for 2. So let's say 3x plus 1 is equal to 2. Solving this gives the solution x is equal to 1/3, and that is not a valid solution, so we know that it has to go 4 to 1. Now we can keep doing this, and we'll see that another solution could be 8. Or, at this point, we have two cases to consider here. 8, 4, 2, 1 or 1, 4, 2, 1. And this is interesting because we know that if our number ends with 1, then the numbers before it have to come 4 and 2. So because of that, we've actually found the next 2 terms before 1, supposing that this term right here is 1. Now we'll return back to the sequence which has 8 instead of 1 here, but focusing on this sequence right now, we see that it has to start with n, and then the second term in our sequence has to go 4, and then we see that it's a repeat. So 4, 2, 1, 4, 2, 1. Now, if you remember, what we just ended up solving here for the number before 4 had to be either 1 or 8. So we can use that to realize that n has to be either 1 or n could be 8 if we end up having the same sequence. So we could have 8, 4, 2, 4, 2, 1, 4, 2, 1, or we could have 1, 4, 2, 1, 4, 2, 1. And those are the only possible sequences we can have that start with 1 at this spot right here. Now, what if we had 8 instead of 1 at that spot? That was our second case to consider if the number before 4 was even. Well, if our number before 4 is 8, then we can go ahead and solve for the term before 8. Either it's double, in which case we'd have 16, or we can solve 3x plus 1 for 8, and we'll end up seeing that this does not have an integer solution, so we know it has to be 16. Now, working backwards one more time, the term before 16 can either be 32, which is double 16, or we can end up solving 3x plus 1 for 16, and we end up seeing that x equals 5 is a possibility instead. So here we have another 2 cases to consider. So our sequence would go 8 or 16, 8, 4, 2, 1, but before the 16 we could have a 5. Now here we have 2 distinct sequences to consider, so let's start with this one instead and finish it off. So n equals 64 is a possibility, just double 32. But what if we had 3x plus 1 is equal to 32 instead? Well, this does not have a solution that's a positive integer, because what we'd end up with is x is equal to 31 over 3, and that's not an integer. So we know that this solution, or this sequence right here, is there's only one of those, there's only one of this, there's only one that starts like this. And now let's go back to this one that starts with the second term as 5. Well, either we can double it, or we can solve 3x plus 1 is equal to 5. We see that this does not have a solution that's an integer, so we know that this also has to be the only sequence. Now, because these 4 sequences are the only possible sequences, we know that we've counted all the possible sequences. There are only 4, and the values of n are the starting values, which are going to be 64, 10, 8, and 1. So for our answer, we simply have to add all of these up. 64 plus 10 plus 8 plus 1 is going to be 74 plus 9, which is going to be 83. So our answer to this problem is E83. Now, if you found this video helpful or interesting, please consider subscribing and leaving a like. If you have any other problems you would like me to cover, please drop a comment down below and I'll do my best to make a video on that in the future. With that being said, thanks for watching.